a device used to store electric charge. A capacitor is a device used to store what? Electric charge. Full stop. Full stop. The capacitance of a capacitor is the ability of a capacitor to store what? Electric charge. The capacitance of a capacitor is the ability of a capacitor to what? Store electric charge. Are you there? Full stop. Mathematically, 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 are you there? Are you there? Yeah. Mathematically, comma, the capacitance of a capacitor is the ratio of charge to potential difference. Mathematically, the capacitance of a capacitor is the ratio of charge to potential difference. Students, look up here. I want to prove a formula. They said the capacitance of a capacitor C is the ratio of what? Charge to what? To V. Are you getting me? Over 1, I cross multiply. Therefore, my Q is now equals to what? CV. This is a very important formula in what? Physics. Are you there? Write it. Then I'm going to give you factors. Factors affecting the capacitance of a capacitor. Factors affecting the capacitance of a what? Capacitor. Factors affecting the capacitance of a what? Capacitor. Are you there? Number one. Number one. Number one. Number one. The factors affecting the capacitance of a what? Capacitor. Number one, the area of the plate. Number one, the what? The area of the what? Of the plate. Student, right. The capacitance of a capacitor is directly proportional to the area of the plate. Are you there? The capacitance of the capacitor is directly proportional to what? The area of the what? Plate. Full stop. Full stop. That means if the plate is large, the area is large, that means the ability of that substance to store electric charge will also be what? Larger. Are you getting me? That is directly what relationship. There is a direct relationship. The capacitance of the capacitor is directly proportional to the what? Area of the what? Plate. Full stop. The higher the area, the higher the capacitance of the capacitor, and vice versa. The higher the area, the higher the what? Capacitance of the capacitor and what? Vice what? Versa. Number next. Number next. The distance of the plate. Distance of the plate. The distance. Student. Student. Some people say the distance of your dielectric material. Also, number two, what the distance of the plate. Are you there? Right. The capacitance of the capacitor. Wait. So before giving me that distance, look up here. Let's do something. If the capacitance of a capacitor is directly related to the area of the plate, look up here. Look up here. The capacitance of a capacitor is directly proportional to the what? Area. Can you see it? That means the higher the capacitance, the higher the what? Area, and vice versa. If I remove this my constant, what do I have? If I remove this, what do I bring in? I bring in what? Constant K. Let's call here what? This equation 1. This is 2. Why this what? 3. Look up here. So my C is equals to what? Ka. If I divide both sides by A, I divide both sides by A, this cancels this. Continue. My K is equal to what? C over what? Over A. At this point, what do I have? I have C1 over what? A1 equals to what? C2 over what? A2. You box this formula. This now what? Equation what? 4. Write that quickly. Equation 4. Hello? Are you confused? Write it now. Equation 4. The next one will now become what? The distance of the plate. The distance of the plate. The distance of the plate. Are you there? Be fast, be fast, be fast. Distance of the plate. Student, equations under capacitor and the capacitor definitely what? Come outside. Electrostatic I taught you will also come out. When I finish from here, I'm going to enter current electricity. This will come out. And after current electricity, I'll now enter what? AC what? Circuit. Then we are done with anything that has to do what? Electricity. All these one and current electricity are under what? DC, which is what? Direct current. Yes. Direct current flows in one way, then alternating current flows what? Yes. Varies. Are you guys done? The next one. The next one. The next one is what? The distance of the plate. Right. The capacitance of the capacitor, the capacitance of the capacitor is inversely proportional to the distance of the plate. The capacitance of the capacitor is inversely proportional to the what? Distance of the what? Of the plate. Then, the capacitance of the capacitor is inversely proportional to the what? Distance of the plate. The capacitance of the capacitor is inversely proportional to the what? Distance of the plate. The capacitance of the capacitor is inversely proportional to the distance of the plate. Full stop. When two things are inversely related, what does it mean? It means one is going up and the other one is what? Coming down. You get it? So if the distance separating the plate is higher, the capacitance of the capacitor should also be what? Low. You get it? Now, look up here. The distance. The distance. The distance. Now, the distance. Everybody look up here. The capacitance of the capacitor is inversely, that's what? 1 over what? D. Are you seeing it? If I remove this one, what do I have? I have my what? K over what? Over D. Therefore, my K is equal to what? Thank you, CD. So what do I have? C1, D1 is equal to C2, what? D2. If I move this one come here, and I move this one here, what do I have? I have C1 over what? C2 is equal to what? D2 over what? Over D1. This is now what? Formula. What is this? Equation what? 5. Are you there? Now, we're going to join the both equations. Everybody look up, stop writing. Now, the first one will say capacitance of the capacitor is what? Is directly proportional to what? Area, and inversely proportional to what? Distance. I mean, if I now remove this one, what will I bring in? I'll bring in my constant. But at this time, my constant will not be K, will not be E naught. Here, this E naught is what? Permittivity. This is a very important formula. This is what? Equation 6. You see, where E naught is what? Permittivity. Somebody say permittivity. Thank you very much. So we'll solve question under this. The light.